we want to evaluate the given double integral, let's first take a look at the region of integration. So the region R is equal to, when we give the region of integration, we usually give the interval for x first, then the interval for y. So looking at the order of integration, notice how the interval for x would be the closed interval from 3 to 4. The interval for y would be the closed interval from 1 to 2. Also notice how we'll integrate with respect to y first and then x. So the region of integration is this square region here in the xy plane. Again, x is on the closed interval from 3 to 4, y is on the closed interval from 1 to 2. Before we evaluate this, let's look at the integrand function f of x comma y equals xy graphed in space over this region. So this graph is pretty busy, but the surface f of x comma y is graphed in purple. The region of integration is this square region here. If we look down on the region of integration, we can see that the purple surface is above the xy plane graphed in yellow, which means a double integral is going to give us the volume below the surface above the xy plane over this region. Let's zoom in on the region of integration for a better view. So here we see the surface graphed in purple, and we're only looking now at the region of integration, which means a double integral is going to give us the volume of this solid here, again below the surface, above the xy plane over this region. So we first integrate with respect to y, treating x as a constant. So we'd have x times y squared divided by 2, or 1/2 xy squared. Let's go ahead and factor out the 1/2. Now these are limits of integration for y, so we'll substitute these values for y and then find the difference. So when y is 2, we have x times 2 squared minus when y is 1, we have x times 1 squared. This would be 4x minus 1x, which would give us 3x. Let's go ahead and factor out the 3. So we have 3/2 times integral from 3 to 4 of just x. And now when we get with respect to x, so we have 3/2 times x squared divided by 2. Again, let's go ahead and factor out 1/2. So we have 3/4, and we have times x squared, which we evaluate at 4 and then 3, and then find the difference. So when x is 4, we have 4 squared, minus when x is 3, we have 3 squared. So we have 3/4 times, this is going to be 16 minus 9, which is 7, which gives us 21/4, or as a decimal, this would be 5.25. So again, this would be the volume below the integrand function f of x comma y over this region in the xy plane, which again would be the solid here below the purple surface. I hope you found this helpful.